This is a regular expression. It was written by an engineer on the firewall team at Cloudflare to catch a category of attack called cross-site scripting. It is 30-odd characters of pattern matching. It does not look dangerous. Most engineers would read it and move on. On the 2nd of July 2019, it was deployed to every server Cloudflare operates. Within seconds, CPU usage across the entire network went to 100%. Not one machine, not one data center, every core, everywhere, at once. Cloudflare sat in front of a large share of the web. When Cloudflare stopped serving traffic, a lot of the internet simply stopped. Customers saw 502 errors. It lasted 27 minutes. But the regular expression is not the reason this happened. That is the part worth understanding. Cloudflare's web application firewall sits between the public internet and its customers' servers. Every request passes through it, and the firewall checks that request against a list of rules, looking for attacks. Some look for injection attacks. Some look for cross-site scripting. In July 2019, there were 3,868 of those rules. Each one is a pattern. Each one has to be checked against traffic that never stops arriving. New vulnerabilities appear constantly, so the rules have to change constantly. In the 60 days before the outage, Cloudflare's firewall team handled 476 change requests. That is one change to the firewall roughly every 3 hours, around the clock, for 2 months. This is not carelessness. This is what keeping up looks like. A firewall that changes slowly is a firewall that is already out of date. The pace is the job. It is also quietly part of the story. Now, Cloudflare does not normally push software straight to production. It has a staged rollout, and the stages have names. First, DOG, a single location where only Cloudflare's own employees route their traffic. If something breaks there, it breaks for staff and nobody else notices. Then PIG, short for guinea pig, a small environment carrying customer traffic from free plans only. Then Canary, 3 locations running real paying traffic. And only after all of that does code go worldwide. That process is deliberately slow. It can take days. Every stage exists to catch something the stage before it missed. On paper, it is a very good system. And on the 2nd of July, it worked exactly as designed. Because it was never asked to run. The firewall rules deliberately skip all of it. And there is a good reason. When a serious vulnerability is published, the proof of concept exploit often appears on GitHub within hours. Cloudflare's value in that window is being able to protect every customer before anyone has had time to patch. A staged rollout measured in days is useless against a threat measured in hours. So firewall rules take a different path. They are not software deployments. They are configuration, and configuration goes out fast on purpose. That decision is not a bug. It is the product. That path is a system called Quicksilver, a key-value store Cloudflare built to distribute configuration to more than 180 cities. It handles around 350 changes per second. And for 99% of changes, the time from push to live everywhere on Earth is about 2.3 seconds. Think about what that means. 2.3 seconds from one merge to every machine Cloudflare owns, on every continent simultaneously. There is no window. There is no gradual anything. 2.3 seconds is normally the feature. It is the thing Cloudflare sells. On the 2nd of July, it was the delivery mechanism. (1331) UTC. An engineer on the firewall team merges a pull request. It is a minor change to the rules for detecting cross-site scripting. An improvement, not a rewrite. It has been reviewed. It has been approved. Everything about this moment is ordinary. That is the point. Nothing here looks like the beginning of an outage. 1337. The build system runs the test suite. The suite fires a large collection of requests at the firewall, requests that should be blocked to check it catches attacks, and requests that should pass to check it is not over-blocking. Everything passes, green light. The change is cleared to deploy, automatically, without a human in the loop. It has done its job. 1342. Deployment begins automatically, and the rule is going out in what Cloudflare calls simulate mode. Real traffic passes through it, but nothing is blocked. It is there to be measured, not enforced. The safest possible way to ship a rule. Quicksilver takes it worldwide. 2.3 seconds. It is now live in more than 180 cities. 1345. 3 minutes later, the first page fires. It is a synthetic test, an automated check run from outside Cloudflare's network, whose only job is to confirm the firewall is working. It isn't. 3 minutes from deploy to first alarm, and for the next several minutes, nobody knows what they are looking at. Then the rest arrive. End-to-end tests failing. A global traffic drop alert. Widespread 502 errors. Reports from points of presence in cities across the world, all saying the same thing. CPU exhaustion. Not one region, not one service. Everywhere at once, within the same minute. When everything fails simultaneously, you lose the one thing that normally tells you where to look. There is no unaffected system to compare against. Cloudflare's CTO was in a meeting and left it when the alerts reached a smartwatch. On the way to the desk, someone from the solutions engineering team said they had lost 80% of their traffic. 80%. That is the figure reported in the room, in the moment, before anyone had time to measure it properly. It was enough. In the first minutes, nobody knew what it was. The initial theory was an attack. Something new, something nobody had seen before, hitting every location at once. That is a reasonable guess. It is also the wrong one, and it costs time. The London engineering team was sitting in an internal tech talk. The talk was stopped. The room became an incident call. 1400. The firewall is identified. The attack theory is dropped. The performance team pulls live CPU data off a machine, and it is unambiguous. 1402. Someone proposes a global terminate, a mechanism built to switch off a single Cloudflare component worldwide. 31 minutes have passed since the merge. 1407. It is executed. By 1409, traffic and CPU are back to normal everywhere. At 1452, after testing the rollback in a single city on non-paying traffic first, the caution that was skipped on the way in applied on the way out, the firewall goes back on globally. 27 minutes start to finish. So, back to the regular expression. Most of it is a long list of characters the rule is looking for. The important part is the tail. And once you strip away the grouping syntax, the part that matters reduces to this. Match anything, then match anything again, then find an equals sign, then match anything after it. Here is what that costs. Take the string x equals x, 3 characters. To decide whether that matches, the engine takes 23 steps. It starts greedy. The first match anything swallows the whole string. Then the engine needs an equal sign, and there is nothing left, so it fails. It backs up 1 character and tries again. Fails. Backs up. Tries again. That is backtracking. Every failure sends the engine back to try a slightly different split of the same string. 3 characters, 23 steps. At this size, nobody would ever notice. Now add characters. It does not grow in a straight line. 20 x's after the equal sign takes 555 steps. And if there is no equal sign at all, so the match has to fail, It takes 4,067 steps to work that out. Add a semicolon, and the same 3-character string costs 90 steps instead of 23. This is the shape of the problem. The cost explodes hardest exactly when the match fails. Now serve that at internet scale, on every request, on every core. And remember, the rule was in simulate mode, blocking nothing. But a rule in simulate mode still has to run. Simulate mode governs what happens after the match. It does not skip the match. Nothing was being blocked. Everything was being evaluated. The safety setting protected customers from the rule's decisions. It did not protect anyone from the rule's cost. Cloudflare's post-mortem does not name one root cause. It lists 11 contributing factors. Not 11 mistakes. 11 things that all had to be true at the same time, and if any one of them had been false, there would have been no outage. This is what a real failure looks like. Not a villain, a list. Some of them are about the regular expression itself. The engine was PCRE, which backtracks, and which has no protection against a pattern running away. The test suite ran the rules, but it had no way to detect excessive CPU consumption. It checked correctness, it did not check cost. And the logs show the new rule caused no measurable increase in test suite runtime at all. There was no signal to miss. It passed because nothing was watching for the thing that went wrong. And then there is number 2, a protection that would have prevented exactly this. A limit on the CPU consumed by a regular expression had been removed, by mistake, a few weeks earlier, during a refactor. And the purpose of that refactor was to make the firewall use less CPU. The safeguard against runaway CPU was deleted while trying to reduce CPU. The rest are not about the failure, they are about the response. Rolling back required a full firewall build, run twice. Engineers could not reach their own internal tools because those tools sat behind the edge that was down. Some had lost credentials to a security timeout. Nothing here was a bad engineer. Everything here was a system that had quietly stopped being able to see itself.